Hello, welcome. This we're going to build a Meshtastic 868 JPole aerial. I do like the JPoles, and the JPoles are a balanced sort of aerial. You connect the inner and the outer of the coax, and you don't need to use the ground plane. You don't need a ground plane, which is the best part about them. They're also 3 dBi above a dipole, so yeah, double your power. Hey, bonus. You've only got a quarter of a watt going in, at least you've got 5.5 of a watt off, well, it's half a watt, sorry. ERP. Right, let's get into it. Right, the basics of a J-pole is you have one element which is long and another element which is short, like that. And then you've got a feed point. Your coax comes into here, so you've got a feed point on there which is a long section, edge of the coax, like that, to there, like that. So what you've got is the length of the long section, you've got length of the short section, you've got the distance between those, and you've got the distance from there to the feed point. And that's pretty much it. The advantage of a JPole is that this section here, you've got the inner and the outer connected to it, and this is a balanced aerial, unbalanced to balanced aerial. So you don't need a ground plane. Just to demonstrate that point, if you've got, say, a dipole like that, and you've got a feed point in the middle like that, and another section there, then you've got a feed to that one, there's your coax, and then your outer to that one, that's a dipole. So that is your driven element, that is your ground plane essentially, and that there is a quarter wave, and that there is also a quarter wave. Now those are quite good. Those have got about 3 dBi, so that will give you the same power as you put into it going out. That will give you double the power that you've got going into it going out. When there are other aerials, there's lots and lots of aerial designs. Quarter wave there, you can have that section, and then ground planes coming off like that, and those are also very, very good aerials. I'm not sure what the gain of that is, but that would be your driven element. So your coax is coming in here, that goes to there, you've got your outer which goes to these here, and then you've got your coax going out that way. So lots of different aerial designs, but this is all we're going for, a J-pole. Now from the calculator, I'll put the calculator up. We've got long section from there to there is 24.9 centimetres. We've got from there to there, which is 8.3 centimetres. That from there to there is 0.8 of a centimetre, and also from there to the feed point is 0.8 of a centimetre. That's calculated. There's a couple of variables, so when we get to this stage here, we'll just wrap the wire around there. We'll try it and see how we get on. Just strip this piece of 2.5 cable and just strip the blue out of it, and I ended up with this. Try straighten it in, just can't straighten it, to be fair. It just doesn't want to go straight. So here's a little technique. So here I've got a piece of wire, which I'll show you how I straightened it, because this is just a piece of 1/4 of a 2.5. So we need at least 8.3 centimetres there. We need 8 centimetres or 0.8 centimetres between them, 8 mil, and this is an 8 mil drill. Let's see if we can get that straight and bend that around the 8 mil drill, like so. There to that. And there we have that nice straight piece, and we can now put on there, do a slight more bend on there just so they're parallel. Yeah, it's not too bad. Not too bad at all. Okay. Yeah, it's not too bad. It's not too bad. Right. Tape measure. So one side needs to be 24.9. So from there, we've got from there, actually one side's 8.3, so I'm going to go with that one first. 8.3 from there to 8.3, and from there we've got 24.9. Range shot. I'm not. This is difficult when you're trying to record it as well. Okay, let's do it slightly different way. Right, from there, 24.9 is about there. Up to that point. Got it. All you have to do there is cut it there. There's my mark, just there. There we go. And that is pretty much that. That doesn't look much like an aerial, but it is. Now, we've already got our 24.9 to there. From there, we've got our 8.3, that's all in centimetres. Our 0.8 of a centimetre between those two. So our parallel bit there. The conductor itself nice and straight. So the only thing we've got to get now is the feed point. Right, so a piece of that on one side, on the other. That is now 1.5. I'm going to chop it. And take a piece of coax and I'll strip the end of it. Be careful doing this. I'm actually a trained professional. Wouldn't believe it now. Okay, and strip this bit of coax out the way into the inner and the outer. Well, this is going to need a bit of Right, there we have it. That's trimmed all the way down there. Just screw all those together, like so. And there you have two conductors, like so. Right, I'm going to trim the centre. And there we go. There's the centre, and there's the outer, just like I draw on the drawing. What we need to do now, there is the driven element, the long one, and there is the counterpoise. Yeah, need to connect those like that. A little bit fiddly at this frequency, I have to say. It doesn't matter about those, but they could do it being roughly equal length, to be fair. Like that. So I've just set this for resonance, and at the moment the aerial's lying on the floor, and it's telling me I've got a 1.6 to 1 SWR. Let's pick him up. Let's pick him up and point him in the air as I'm just sort of holding it by the cable and pointing him up. There we go, 1.3. That's 867 250. It's not far away. That's not far away at all. I could mess around with it and get a little bit closer just by sliding the sliding these, to be fair. Full disclosure, to get the blow lamp on it. Just to get those connected, because my soldering iron's a bit struggling a bit. But just those, I can move those. So you basically move those up and down. It's quite twitchy because it's a small aerial, but you move those up and down there to get the right place, and then as you can see, solder it. That's seen. Focus. Yeah, there you go. Close. No, that's better. So that's connected to there. And let's see if we can pick up something with that. The only thing I'm going to do next is to pull this whole thing into a piece of white conduit. Throw some silicon in there so it's completely enclosed in white conduit. So do not, under any circumstances, use black conduit. There was an instance where I think it was the French player, a fella, Gilles, tech prepper, I think he goes by. Had a conversation with him, and he'd spent hours producing a coil former on a 3D printer, and he wound this coil and it didn't work, and the coil happened to be black. So I think that was the problem. And also Callum at DX Commander also had some formers to hold or spacers to hold the spacing in place with the DX Commander. I think he had those, and they turned up in black and they melted. So something to do with the pigment, not quite sure what it is. I've tried doing the JPoles on a previous occasion, different frequency, but popped it into a piece of black conduit and the SWR went completely wayward. So yeah, don't use black. Other than that, thank you for watching. If you like the content, click and subscribe. See you again. Bye bye.